Okay, so here I have a field effect transistor circuit, and I'm applying this is the gate right here, and it's set at what, some nanovolts something, which is almost 0 volts. So if you apply on an N-channel field effect transistor 0 volts, it's going to be conducting as hard as it can. By the way, I suggest that you build this circuit yourself and see how it works. It's one thing to listen to me or to watch me do it, but I think it'll be very helpful if you build it. It's not a complicated circuit to build. So this is an N-channel device, and the source is connected to ground right here, and the drain is connected to VCC, which is 8 volts. And when it's conducting fully, I have about 3 milliamps, something like that. And I have 300 millivolts across this resistor. Remember that this current going through this resistor here will be the same current going through the transistor to ground. And I'm controlling the gate voltage through this potentiometer. And notice that it's connected to minus 5 volts. Because remember, to make this throttle or to reduce the current, what you need to do is to increase the negative voltage. So right now I have 0 volts, and it will be conducting as hard as it can. So let me slowly increase the negative voltage. So you saw how the source current, the drain current went down. So negative 25 milliamps. So it's became 3 milliamps to so it's 3.1, because 3.18 right before this. Okay, so you see how the current is going down. So the current keeps going down because I'm increasing this voltage right here at the gate. I'm increasing the gate voltage right here, and as I increase the gate voltage, this voltage goes down. You see how it's going down? So it's 2.5 milliamps, something like that. So I have 2 milliamps right now, and I have 400 millivolts at the gate. Keep increasing that. So we go up to about 1 volt. So you notice this is increasing. So I have actually I said negative 1 volt. So it's negative 1 volt, and you notice that the transistor is almost shut off. It's 800 microamps, 810 microamps. So 0.8 milliamps. So 300 to 3 to 0.8. So I'll keep increasing. Go up to about negative 2 volts. Negative 2 volts, I have 1 microamp. So that's about half of the power, half of the potentiometer, right? So I have 1 microamp, and I had what did I do to this thing? 3 milliamp to 1 microamp. 3 milliamps to 1 microamps. You can see how much the current has dropped. I mean, it's almost negligible at this point. Another interesting thing is this source voltage is, you can look at this device and see it's 8 volts being dropped across this device. So for all practical purposes, it's shut off at this point. I think if I increase the voltage some more, it'll drop, but it's such a small number now. It's 800 nanoamps, which is almost nothing, right? So 3 milliamps versus 800 nanoamps. And you also notice that this voltage here is what, 0.08 millivolts. Such a small voltage. It's almost negligible. Okay. So here it's conducting as much as it can. Now notice that this voltage here across the drain source doesn't change a whole lot. And the reason is that this channel here is a fixed resistance. So even though this is conducting, this voltage does not change. It's not like a bipolar transistor, which is like a switch. It doesn't work like that because this channel is a fixed resistance. So you will always get this voltage drop. So I suggest you build this circuit yourself and see how it works, because there'll be quite a few questions in the test on this subject.